Okay, so 9.6, we're going to talk about secants to a circle. So a secant is a line that cuts through a circle. So it's kind of like a chord except it extends. And so we're also going to refer to tangents and other parts of a circle as well that affect a theorem. So there's going to be two theorems that we talk about. So the first says if a secant, which would be AB, and a tangent line, so let's just call this line A, intersect at the point of tangency, which is at A right here, and the measure of each angle formed is half the measure of the intercepted arc. So it's not really an inscribed arc, so we just call it an intercepted arc. So you'll notice here, arc AB, okay, that intercepts or is related to angle 1. And so what's that saying is that angle 1 is going to be half the measure of arc AB. And that's it. So it works on either side. So if we look at arc BCA, well, the intercepted angle is angle 2, and that's why it's in blue. And so it's going to be half of that arc. Okay, and so vice versa. You could also say if you have the angle measure, then that, intercepted arc is twice the size of the angle that's formed. All right. Also keep in mind some other relationships. Since we do have a tangent line, both of these two angles have to add up to 180 because remember both of the total length of the arcs add up to 360. All right, let's look at some examples. So on part A, it says find the measure of angle QPR. So here's QP to R. Remember to go in order. So this is the angle that we're looking for. I could also have found the other angle measure, but we'll do that later. So if I know that's the angle, its arc that is intercepted is arc PR. And so if that's 148 degrees, we'll take half of that. So 74. Okay. So keep in mind, I could have also found this angle measure because these two add up to 180. All right. Example B, find the measure of angle DEF. So here's DEF. And I think they might mean to say arc. That's what we're going to change it to. Well, we have two choices. So if I know that this is 64 degrees for this angle, that means the arc is going to be double that. So that's 128. Okay. We want this arc. So remember, a whole circle is 360. So if we take off the part that we know, it's only really made up of those two different arcs. We would get 232 degrees. Okay. All right, the second theorem, we've seen this before, this third scenario, but there's two new scenarios that are also true. So I thought I would add that in here. So we can have two secants. So that's right here because they go through the circle. We can have a secant and a tangent. Or we've seen this before, we can have two tangents. Okay. If they intersect on the exterior of a circle, then the measure of the angle formed is half the difference of the intercepted arcs. Okay. So we talked about these being congruent, but now we're actually going to talk about the angle measures. So this really is new for all three scenarios. So let's look at the first part. If we want this angle, which we'll call that angle A, it's going to be half of BE minus this BC. Okay? And so this doesn't talk about the actual lengths themselves, it talks about the angles. So same thing here, if we want angle A, it's going to be half of arc BC minus arc BC. And then our third scenario, angle A, is going to be half of arc BDC minus BC. Okay. So they all kind of look different. I think the second one's probably the hardest one to see or kind of visualize, but they all work. All right, I just showed two examples. So on the first one, it says find the measure of angle L. So we have two tangents, so that's going to be our third scenario. So if we want angle L, that's equal to half of, well, we need to find this outside arc, and we know the inside arc. So the inside arc is 102. We know the total of the arcs equals 360, so we'll do a little bit of work on the side. So 258 is going to be this red arc. So 258 minus 102. You can use a calculator. So I know I'm taking half of 156. So angle L is equal to 78. Looks pretty close. All right, this one's a little different. So we have a tangent and a secant. So we know our angle, I'm going to write it out, is equal to half of our outside arc minus our inside arc, BC. Well, I know angle A, so that's 56. And half of, we know this arc is 95. And you can think about this logically. You don't have to use an equation. And then I could find this measure, except that part's missing. So that's why we want to use our formula. So we're going to let this be x. Okay. So to solve this, once again, we'd multiply by 2. So 112 is equal to x minus 95. So we'll add 95. So x equals, if we add that together, 702, 207. It looks a little bit more than half a circle, but trust your math. All right, go ahead and give your practice problems a try, and good luck.